Is the slide visible?
Yes, sir.
Okay, so there was some disturbance in the internet connectivity, due to which we lost somewhere in between. So let us continue with the discussion. Okay, we are discussing about the psychrometric processes. Okay, so let us start. We have discussed about this process number 1, sensible heating. Then we have seen for the sensible cooling process as well in the opposite direction. We have also shown this process number 3, okay, which is nothing but the humidification. And I will keep the pointer at the same position. Okay, is the pointer visible to you?
Yes, sir.
Right. So I will show you the process number 4. So have a look at this fourth process. Okay. So I have shown the green colored arrow, and this arrow is also vertically in the downward direction now, exactly opposite to that of what the process 3 I have shown. So this process is known as the dehumidification. So what is happening with the temperature with this process?
Sir, the temperature remains same and specific humidity decreases.
Okay, yes, that's very good answer. So your specific humidity or the moisture content in the air that reduces, whereas the dry bulb temperature that remains constant. This process is known as the dehumidification. Okay, so these are the two fundamental sensible heating, cooling, and then two fundamental process which deals with the change in the specific humidity, that is the humidification and dehumidification. So in heating and cooling process, there is only change in temperature, but there is no change in specific humidity. Moisture content of the air does not change. But in humidification and dehumidification, the temperature remains constant, but there is a change in the moisture content, or there is change in the specific humidity of the air. Have you understood the meaning of these processes?
Yes, sir.
Okay. Now let us see these processes one by one in detail. Okay. So initially, I will discuss about the arrangement for the sensible heating process. Okay. So you can also write down this title on your notebook, sensible heating. So I am having a one block diagram at the left side. And I have shown this, let us say, as one duct. Okay, there is a one duct, and this is the inlet of the duct. Okay, this is the inlet of the duct, and this is the outlet of the duct. Okay, and as I am say dealing with the heating process. Okay, so inlet air will be at low temperature. So inlet air will be the cold air. So that's why this blue color arrow is shown to represent that it is the cold air. And whereas at the outlet, the red color arrow is shown. So it means that the air is warm, the air is heated, isn't it? So air in, so that is at condition 1, okay, and air out, so that is at condition 2. So 1 point will represent the inlet condition of the air, and point 2 will represent the outlet condition of the air. So when the air passes through this duct, so you are fitting somewhere in between a coil. Okay, so this is nothing but the coil, which is consisting of the multiple number of turns. Okay, and through these coils, either you are passing any hot fluid. So for example, here it is shown that steam is passing. So steam is entering into these coils, It is passing through these coils with the multiple turns, changes in the direction, isn't it? And it is due to this steam. Let us say it is coming out at condition 2. Let us say it is coming at the other end of this coil. The steam is coming out at the other end of the coil. And when the steam passes, hot steam passes through this coil, or the hot water, or you may pass the hot gas also through these coils. Okay, so this coil is known as the heating coil, and its condition is shown as 0.3. So definitely if it is a heating coil, its temperature will be high, and the air which is admitted at condition 1, TD1, that is a dry bulb temperature of the air at inlet. Okay, so this air at low temperature is getting admitted into the duct, and air comes in contact with the hot surface of this heating coil. Okay, as the hot fluid steam is passing through the coil, so definitely the surface temperature of the coil will be very high, isn't it? Coil surface temperature will be very high, it will be hot. So as the air comes in contact with the hot surface of the coil, the air picks up the heat. Okay, air picks up the heat from the hot surface, and it is then heated to the required temperature, that is nothing but the TD2. Okay, so if we show these points on the psychrometric chart, okay, so on this side you are having a blank psychrometric chart, and it is a dry bulb temperature that is on x-axis, and specific humidity that we represent on the y-axis. So let us show these points, point 1, point 2, and point 3, and the process of the sensible heating on the psychrometric chart. So see it very carefully. Okay, step by step I have represented these processes on the psychrometric chart. Okay, so have a look at carefully. So this is nothing but my point 1. And at this point 1, let us say I know the two psychrometric properties. Let us say dry bulb temperature is known to me and relative humidity is known to me. Okay, so with the known values of the dry bulb temperature TD1 and relative humidity phi1, I will be in a position to mark the position of the point 1 on the psychrometric chart. And if this point 1 is marked, I can note down what is the enthalpy at point 1. Okay, so H1 that will be known to me. Okay, so initial condition is represented. Now let us see the other point, next point. So I should know that up to what temperature I should heat the air. What should be the outlet temperature of the air? So that will be known to me. It means that let us say I want to heat from 10 degrees Celsius to let us say 25 degrees Celsius, isn't it? So this 25 degrees Celsius temperature is known to me. The relative humidity will also be known to me. So with this dry bulb temperature and relative humidity phi2, I will plot the point 2 in a similar fashion, the way in which the point 1 was plotted. I will also record what is the enthalpy at point 2, that is H2. Okay, and I will show this process with the horizontal line. In the previous slides, we have seen the process number 1, sensible heating. So that was shown in the horizontal fashion, and the arrow was shown toward the right. So similarly here also, the arrow is shown toward the right hand side. I should also show the point number 3. Okay. So can you tell me that whether this point number 3, so that will be on the right hand side of the point 2 or the left hand side of the point 2? And why? Yes.
सर थर्ड पॉइंट पण हिटिंगचाच असणार ना?
Yes. It is nothing but the surface temperature of the coil. Isn't it? Point 3. It is the heating coil surface temperature. So heating coil surface temperature will be greater than the temperature at point 2 or lower than the temperature at point 2?
So greater than.
Greater than. So
Greater
where
than
will be the point number 2 then, on the left hand side or on the right hand side of the point 2?
right hand side, sir.
Right hand side. Okay, so let us see that whether it is on the right hand side or not. Yes, the point 3 will be on the right hand side. Right. So this way, the sensible heating process will be represented on the psychrometric chart. Okay. So what is expected to write down if this question is asked to you? Explain the process of sensible heating. Okay, with the help of the suitable sketch and psychrometric chart. So you should draw this sketch. Okay, you should write down the description of this block diagram. And then represent the process on this psychrometric chart in this fashion. And then you should write down the sensible heating is a process where the dry bulb temperature of the air increases without change in the moisture, or there is no increase or decrease in the specific humidity. Okay, specific humidity will remain constant. So I can show that one. Yes, omega 1 equal to omega 2. Understood?
Yes, sir.
Okay, so this information, this answer should be written for this question if it is asked in the examination. And write down this equation. The heat added during sensible heating. Okay, write down this formula, write down this equation. The heat added during sensible heating, that is Q equal to difference of enthalpy, final enthalpy minus initial enthalpy. Okay, heat which is added to this coil. So that is the difference of final enthalpy minus initial enthalpy. And it can be also written as 1.022 into TD2 minus TD1. So TD2 is the final dry bulb temperature and TD1 is the initial dry bulb temperature. Got it?
Yes, sir.
Now exactly opposite of this one, sensible cooling now. Isn't it? So same duct is taken into consideration here. And here the arrow at the inlet, so that is shown by the red color, and the arrow that is at the outlet, so that is shown by the blue color. So red color represents the hot air and the blue color represents the cold air, because our purpose here is to cool the air, isn't it? So inlet temperature will be high, it will be hot air, and at the outlet the temperature will be low,
Cold.
or it will be the cold air.
Cold air.
So I am having a coil here. So instead of heating, now this coil will be the cooling coil, because I
Yes,
want
sir.
to cool the air. So I will admit the refrigerant inside this one, refrigerant or any cold gas, chilled water also. So that can be passed through this coil. Instead of hot fluid, I need to pass the cold fluid. So it is shown here, that is the refrigerant in. So that is entering here. It is passing through the coil. Okay, keeping its surface temperature very cold, that is TD3. And it is leaving at other end, that is the refrigerant out. Okay. So TD1 dry bulb temperature here, TD2 actually. This should be TD2, outlet temperature of the air. And surface temperature of the coil is TD3.
सर तो रेफ्रिजरंट आतमध्ये जातोय तो हॉट असणार आहे ना?
Refrigerant?
इनच्या
Hmm.
इन जिथं होतोय तो हॉट कंडिशन मध्ये असणार ना?
No, it will be cold. If it is hot, then this will not be a cooling coil, na, then.
येस.
It should be the cool. So that the surface temperature of this coil has to be cool. It should be very low. Then this air will lose the heat and air will get cold.
येस सर. ओके ओके.
So let us show this process on the chart as well. So this is your point 1. Okay. The way in which it was shown for the sensible heating process. So similarly, the point 1 will also be plotted here. And point 2, that will be known to you. It means that up to what temperature I should cool the air. So that will be known to us. So we can show the point number 2 this way. Isn't it? So there is a drop in temperature from TD1 to the TD2. Okay, initially this was the temperature TD1 and this is the final temperature. So there is a drop in temperature from TD1 to the TD2. It means that air is getting cooled. And point 3 now. Okay, coil surface temperature. So point 3. Okay, this omega 1 equal to omega 2. Okay, similarly, it was there for the sensible heating process also. Point 3 will be there on the left hand side. So that is a TD3, surface temperature of the cooling coil will be shown like this one. Okay. So have you understood the difference between the sensible heating and sensible cooling process?
Yes, sir.
Good. And if I extend this line further, that is 1, 2, 3, so I can reach only up to the saturation curve. And wherever it cuts the saturation curve, so I write down this as the TDP. It means that the dew point temperature. It means that,
सर तिथं तिथं पूर्ण चिल्ड असणार ना म्हणजे
yes. So it will be shown here that the sensible cooling can be done up to dew point temperature. So you can carry out this process up to the dew point temperature. Very low temperature will be obtained here. The cooling below this temperature will result in the condensation of the moisture. Okay, we know the definition of the dew point temperature. So it is the temperature where the moisture present in the air that start condensing, isn't it? Water vapors are converted into the liquid water at the dew point temperature. Okay. And the equation to calculate here, that is amount of heat removed. Actually, it should be amount of heat removed during the sensible cooling. Please make a correction here that it should be the cooling process. And instead of added, it should be removed. Amount of heat removed. Okay, instead of added, it should be the heat removed. And here it should be sensible cooling process. Okay, so initial enthalpy minus the final enthalpy. H1 minus H2. And it can be also written in this equation 1.022 times the TD1 minus TD2. Inlet dry bulb temperature minus the outlet dry bulb temperature. Okay. Now let us go to the next process. Okay. Now bypass. Okay. Before going to the process number 3 and process number 4, we'll see this concept known as the bypass factor of the heating and cooling coil. Okay. So in the two processes that we have seen, it is observed that the temperature of air coming out of the apparatus will be less than the surface temperature of the heating coil. It means that TD2 is less than the TD3. How it is? If it is heating process. So here TD2 is less than the TD3. Okay, this is your TD2 and this is your TD3.
TD3.
Okay, so in the heating process, the temperature at point 2 is less than temperature at point 3. But whereas in the cooling process, the temperature at point 2 is greater than the temperature at point 3. Okay, in the sensible cooling process, temperature at point 2 is greater than temperature at point 3. So if this is true, so that is what it is mentioned here. The temperature of air coming out of the apparatus, that is the TD2, will be less than the surface temperature of heating coil. Whereas in case of the cooling coil, the opposite is this one. The temperature of the air coming out of the apparatus will be more than the surface temperature of cooling coil. These are the
सर
observations.
हे बायपास फॅक्टरची डेफिनेशन आहे का
No, it is not the bypass factor definition. It is the observation that we are having. Definition will be in the next slide. So this is what the concept of the bypass factor that you are having. Okay, let us say bypass factor for the heating and cooling coil. So this is your duct. Okay, let us say this is your duct. It is nothing but the insulated duct. Air is admitted at point 1, let us say TD1. Air is coming out at some different condition, let us TD2. And you are having some coil in between. Okay, this is the inlet. Okay, this is the inlet of the air. This is the outlet of the air. And at some intermediate place, some middle of this arrangement, you are providing heating and cooling coil. Okay, let us say the heating or the cooling coil is placed. So what it is stated, let 1 kg of air at temperature TD1 is passed over the coil having the coil surface temperature TD3. Okay, coil surface temperature is TD3. So it is x kg of the air bypasses the coil and 1 minus x kg of the air comes in direct contact with the coil. It means that I am admitting 1 kg of the air. So all the air will not come in contact with the surface of this coil. Okay. Some part of the air that will remain unaffected. So that will bypass. That will not come in contact with the surface of the coil. Out of this 1 kg. So let us say x kg of the air is bypassed. Okay. So that air doesn't come in contact with the surface of the coil. And the remaining is 1 minus x. Okay. So this 1 kg is bifurcated now. X kg and 1 minus x kg. So 1 minus x kg that comes in contact with the surface of the coil. Okay. So this portion of the air is only cooled or heated depending upon whether it is a heating coil or a cooling coil. So 1 minus x kg and this x kg. So again, it is the 1 kg of the air that is coming out. Okay. So that is mentioned here. X kg of the air is bypassing the coil. So x kg of the air is bypassing the coil, that is not coming in contact with the coil. It is unaffected. And the remaining air, 1 minus x kg of the air comes in direct contact with the coil. So 1 minus x kg of the air. So I have shown that with the help of this arrow, the air is passing over the cooling or heating coil, depending upon whether you are carrying out the heating process or the cooling process. So this bypass process of air, that is unaffected air to the coil, is measured by a term known as the bypass factor. Okay, so bypass factor represent the portion of the air, that is x kg of the air, that is bypassed or that is not coming in contact with the surface of the coil. It is remaining unaffected. So bypass factor is undesirable then. Bypass factor is undesirable. And this bypass factor depends upon various factors. And some of the factors are represented on this slide. Okay. The bypass factor that decreases with the fin spacing, and the bypass factor that also decreases with the increase in the number of rows of the coil. Okay. And by appropriately applying the first law of thermodynamics or the energy balance, you can calculate the bypass factor. Okay, so bypass factor is normally represented by a symbol X. Bypass factor is represented by the symbol X. So write down this formula for bypass factor of the heating coil. If you understood the sensible heating process, point 1, 2, and 3, then for that heating process, the bypass factor is given by this equation. Bypass factor of the heating coil equal to TD3 minus TD2 divided by TD3 minus TD1. Or in other words, this TD3 is nothing but the coil surface temperature. Okay, coil surface temperature, and TD2 is nothing but the air outlet temperature. Okay, so in the numerator, it is the coil surface temperature minus air outlet temperature divided by coil surface temperature minus air inlet temperature. So you have to remember this formula. Okay, bypass factor of the heating coil. Similarly, I can also write down the bypass factor of the cooling coil. So that way the bypass factor of the cooling coil can be written TD2 minus TD3 divided by TD1 minus TD3. So TD2 is nothing but the air outlet temperature. TD3 is nothing but the coil surface temperature. And TD1 is nothing but the air inlet temperature. Okay, so bypass factor represents the portion of the air which is not coming in contact with the surface of the coil. It is simply getting bypassed. The portion of the air remains unaffected. It means that there is no heating or no cooling of that portion of the air. Okay, so it is nothing but the undesirable parameter. Bypass factor should be as low as possible. So this is the conclusion based upon that discussion. The performance of heating or cooling coil, so that is measured by a term known as the bypass factor. And if you are having a coil which possesses the low value of the bypass factor, so that will have a very good performance. Okay, coil will be having an excellent performance if it possesses the low value of bypass factor. And if I write down 1 minus the bypass factor, so that is known as the efficiency of the coil. Okay, efficiency of the heating coil or the cooling coil. So that is written as 1 minus bypass factor. So this efficiency of the coil is also known as the contact factor. So I can write down now the efficiency of the heating coil by the equation that is shown at the bottom. Okay, eta H, that is efficiency for the heating coil. The efficiency is the 1 minus bypass factor. So 1 minus, we have seen what is the bypass factor for the heating coil, TD3 minus TD2 divided by TD3 minus TD1. You simplify this equation and you will get the TD2 minus TD1 divided by TD3 minus the TD1. Okay, efficiency of the heating coil. On the parallel lines, you can also write down the efficiency of the cooling coil, eta C. C stands for the cooling coil. So 1 minus bypass factor of the cooling coil. So 1 minus TD2 minus TD3 divided by TD1 minus TD3. Or it is, after simplification, we can have it TD1 minus TD2 divided by TD1 minus TD3. Okay, so you should remember the equations for bypass factor of heating cooling coil and efficiency of heating and cooling coil. Is that fine?
Yes, sir.
Okay, now the next process. Write down this title in your notebook, humidification. And write down the definition as well. Okay, write down these 2 lines, 2 paragraphs. Addition of moisture to the air without change in its dry bulb temperature is known as humidification. A simple definition for the humidification. Addition of moisture. It means that you are going to increase the moisture content in the air. And during this process, the dry bulb temperature will not be changed. It will be constant. So let us show this process on the psychrometric chart. Okay. So see how this process can be shown. Okay, let us say this point 1 that is known to you. Okay, so dry bulb temperature is known to you, and let us say relative humidity phi1 is known to you. So if you mark this point 1 on the chart, you can also know the value of omega 1, the specific humidity at the inlet, that will be known to you. And we know that the humidification process will be shown by a vertical line from the point 1 now, isn't it? So how it will look? So let us see that as well. So this way, the process 1 to 2 will be shown, isn't it? Relative humidity is phi2 and the dry bulb temperature is constant, TD1 equal to TD2, isn't it? So here it is mentioned without change in dVT. Okay, without change in the dVT, and there is the addition of moisture. So addition of moisture, it means that initially the specific humidity is omega 1 and finally specific humidity is omega 2. So there is increase in specific humidity from omega 1 to omega 2. Okay. So that way this process can be shown on psychrometric chart and this definition as well. You can see that the initial enthalpy is H1 and final enthalpy is H2. So heat which is added during this process can be represented as H2 minus H1. Okay, dry bulb temperature during humidification process remains constant. Hence, the sensible heat also remains constant. Okay, general observation that you have. And read these lines. Okay, read this paragraph at your own end. Okay, the meeting will end possibly there in the next 10 minutes. We'll complete one more process. Okay, humidification. So this is the what heat which is added during the humidification process. It is known as the latent heat which is added. So it is the final enthalpy minus initial enthalpy, H2 minus H1, or it is also written as HFG into omega 2 minus the omega 1. Okay, W2 minus the W1. And we know that what is the meaning of HFG, that is the latent heat of vaporization. So that will be known from the steam table at the given dry bulb temperature. Then the another fourth process is the dehumidification. Exactly opposite of that one. In the humidification, there was addition of the moisture. Here, it is the removal of the moisture from the air. It is the removal of the moisture from the air at the constant dry bulb temperature. So let us show this process on the chart as well. Okay, in the similar fashion, I will show this process also. Point 1. Okay, with the dry bulb temperature TD1, relative humidity phi1, specific humidity omega 1, enthalpy H1. Okay. Now the point 2 in the downward direction. Okay. So you are having the phi 2, omega 2, and H2. So again, it will be seen that the dry bulb temperature constant, TD1 equal to TD2. But there is a decrease in specific humidity from omega 1 to omega 2. Okay, there is a drop in specific humidity from omega 1 to the omega 2. And heat removed during this process, dehumidification. So that is also the latent heat which is removed. So that is shown as H1 minus H2. Or in other words, it can be also represented as HFG into omega 1 minus the omega 2. And similarly, again, HFG is the latent heat of vaporization. Is that okay? And write down this as well, the sensible heat factor. So sensible heat factor, also known as the sensible heat ratio. And it is defined as the ratio of sensible heat to the total heat. Okay, the ratio of the sensible heat to the total heat, that is known as the sensible heat factor or sensible heat ratio. And it is written as sensible heat, that is SH, divided by sensible heat plus the latent heat. So the total heat is nothing but the addition of sensible heat and the latent heat. So sensible heat factor is defined as a ratio of sensible heat divided by sensible heat plus latent heat. Is it understood? Yes, Rutik, Rishikesh.
Yes, sir.
Okay, so we have seen the four
Sir,
different processes. We have seen the four different psychrometric processes: sensible heating, sensible cooling, humidification, and dehumidification. And the block diagram of the sensible heating cooling process, that also we have seen, and how to represent the sensible heating process, sensible cooling process on psychrometric chart, that also we have discussed. Then what is the humidification, what is the dehumidification, how this process is shown on the psychrometric chart, that also we have shown. And the concept of the bypass factor, that also we have discussed. The equation for the bypass factor for the heating process as well as the cooling process. So that equations also we have seen. 1 minus bypass factor, that is nothing but the efficiency of the coil, that also we are knowing at this stage. And at the end, it is nothing but the sensible heat factor, the ratio of the sensible heat and the total heat. So these are the points that we have discussed.
yes, sir.
Fine.
Sir, येस सर. सर एक्झामला पण विचारलं की ह्या डायग्राम आणि हेच डेफिनेशन काढायचे ना सर?
Yes. This should be done.
येस सर.
So we're almost toward the end of this particular this first part of this Zoom meeting. Okay, so we'll stop here,
येस सर.
and after 5 minutes we'll join again.
येस सर.